Hey, this is Mark, and today I'm going to be working on this. Wow, look at that. I'm going to be working on this iPhone 6 Plus that has no image. So this right here, this kind of glue along the top of the CPU shield, combined with this mark right here, is a pretty clear sign that this board has been refurbished by Apple. This is what they do. Seen enough of them now. So I don't really have any history on this. There's no liquid damage, but just suddenly there is no image. So the first thing I'm going to do is just do a visual inspection under the shield here and see what things look like. The very first thing I did was check for long screw damage here, and then also the image filters. They look okay. The underfill's not burned up over them, so that's usually a sign that they aren't the problem. This is the chip that generates voltages for image and for touch. His name is Chestnut, so one of the things I want to do is look and see if it looks like there's any damage to Chestnut. Sometimes techs can get in with tools and like damage the chip accidentally, but it looks fine. So changing Chestnut is pretty straightforward. So for me, it's kind of like a troubleshooting step. Rather than taking my multimeter out and probing and measuring different lines when the phone is on, I can just quickly rule out the possibility that it is Chestnut by going ahead and replacing Chestnut. So that's going to be my first step here. So this is one of the few chips that is used all the way from the iPhone 5C and 5S is the first implementation in an iPhone of this Chestnut chip, all the way up to the newest ones. The 7 and the 7 Plus both have this exact same chip in them. It's kind of interesting. Over time, Apple's changed a lot about the circuits in these phones. And I mean, even with TriStar, they use newer versions of TriStar, but Chestnut is always the same in all of them. All right. So maybe, if I'm lucky, my random guess as to what the problem is will be the correct solution. I don't ever get that lucky, but maybe. So still, we got nothing. No backlight, no image. So the next thing I'm going to do is check and see which, I can't remember where to measure for LCM enable, which is the enable pin of Chestnut that tells Chestnut to turn on and do its job. So now that I've ruled out the possibility that Chestnut is bad, I want to make sure that it's being told to turn on. So let's see. I know it's one of these guys. There's Photon Live. LCM reset. There we go. LCM to Chestnut power enable. So it's these two little guys that are the second and third from the beginning after these three that are moved back. All right. So let's see. Got these three that are kind of moved back, and then 1, and then 2 and 3. So 2 and 3 are what we need to measure here. Hopefully I can get my multimeter probe in there with the screen connected. Now, this one here is a filter, so I can measure on the back side of it. So that'll work. All right, screen connected, battery connected. I'm going to power it on, and I'm going to measure in DC voltage for 1.8 volts, and I do have 1.8 volts. So, all right. Now I know that Chestnut is being told to turn on. So the next step is to see if the boost part of Chestnut is working. I know there's 2 capacitors on the back of the board, which I can check. I believe it's these 2. So I'm going to check in diode mode and see if there is a short to ground. I know some of these are related to image, but I can't remember which is which. So I'm just going to probe around and see if any are shorted to ground. All right. So let's see, I think this one is also. All right, now I'm going to check on 1.8 and 5.7. I think this is the 5.7 and this is the 1.8. I know this is the 5.7 filter. So I've got 0.103 on it. And this is the 1.8 filter. I've got 0.316. This 0.103 seems low to me. I'm just going to compare that to my known good board. That's not my known good. There we go. Let's see, 528 on my known good and 104 on the board in question. So I will go back to ZXW. And yep, that is my 5.7 line. So let's see what all is on it. Okay, so there's a capacitor here, one here, and one here. So I've got to kind of guess which one of these is going to be the blown one. I'm going to start with this one, and we'll see. Well, I guess I'll be replacing that with one from a donor board. It is gone. All right, let's see if this changed my diode mode reading. Nope, still 104. So next culprit, next possible culprit is going to be, I believe it was this guy. Let me just double check. No, it was this guy right here. So I'm going to pull him off. So yeah, it was this guy right there. We'll pull him off. that was the source of the short. Now I've got 480 and climbing as the board cools off. So now I should be able to test, and we should have image again. Maybe, if I'm lucky. There we go. All right. So that is good to go. It is booting into recovery mode. I already knew it was doing that, but the problem I'm here to solve is no image. The recovery just means it's going to need a restore before it's done. So now I'll get my donor board and swap these caps back over, and then I'll be done. All right, put the shield back on. It's not wanting to sit down because of that. All right, I'm just going to do it with hot air, because that hole is full of solder and there's a leg on it that goes into the hole. All right, that one's done. Thanks for watching.